Math 3, Unit 10, Section 3. Today we're talking about coterminal angles and evaluating trig functions. Okay, yesterday we already talked about most of this stuff. We talked about standard position. Okay, one side starts on the x-axis there and the other one ends somewhere on here. Okay, we talked about positive and negative angles. Okay, positive is when we're going up and around, which is counterclockwise, where negative is when we're going down and around, which is clockwise. The new one today that we're talking about is coterminal angles. And so if two angles in standard position, if they have the same terminal side, they are coterminal angles, meaning they're terminating or ending at the same point. So if you look at this picture right here, these are coterminal angles. One is the positive side and it ends here at 135 degrees. One is going negative, and when it goes negative, it's ending here at negative 225 degrees. Those are coterminal because they terminate at the exact same spot. Does that make sense? Okay, so part of the day, or part of the problems, is that they want us to give an additional positive coterminal angle and additional negative coterminal angle. So I think it's easiest to look at this in a picture. Where would 100 degrees be if we were to put it in standard position? Very good, quadrant 2. So we're going to go ahead and mark this right now, and this is at 100 degrees. We need two more angles. So I want you to think for just a minute about what you could do in order to make another positive angle that ends at this same spot. So what are you thinking? At 360. Do you guys agree that if you went around another 360 degrees, you would end up at the same spot? So what would that angle be? 460. So the positive coterminal angle is 460 degrees. And you don't have to draw these pictures. I'm just trying to show you what's happening. So what happened is you had a whole 360 plus 100, ends at the same spot, gives you 460 degrees. Now, the negative coterminal angle, this would be where we would start at 0, but go backwards to get to this point right here. What would that value be, or how could you find that value? You're really close.
Negative 260.
Negative 260 is correct. Now, some of us might not know how they came up with that number. Does anybody know the process that you could go through to find that number?
Well, it's isn't it because it wraps all the way around, and that would be negative 270 on top.
He didn't raise his hand, you're better.
So if you look at this, you guys, I'm trying to give you a visual so that this will hopefully make sense to you. So we know this part is 100, right? So we're basically trying to figure out, well, what is the part from here to here? I should have highlighted the blue part. So what is the value from here to here? Well, that makes a whole circle. Do you guys agree? So the negative and the positive end up making 360 degrees. So all you really had to do was take 360 minus 100, and that gives you 260, which is how far you would go negative in order to get to that point. So negative 260 is the negative angle. Do you have any questions on that one right now? So we're going to try another one. We're going to see if we can do this. So here on this one, it's negative 400 degrees is our first angle. Where will that end in? Which quadrant? Very good. Quadrant 1, because 400 is going to go 360 all the way around 360.
I was right, I get a piece of candy.
Quadrant 4, right? You'd have to go an additional how much? Okay.
I'm pretty sure that I got this candy.
I'm pretty sure you guys need to be quiet, and no one's going to get candy unless we can get through this lesson. Okay, so negative 400 degrees.
Ouch.
So we need a positive and a negative. So I'm going to give you guys a few, maybe just a minute, to try to think through what could be a positive and a negative. So we're looking for just a number other than negative 400 that would end up at this same spot, and one of them being a positive number and one of them being a negative number. If you have it, raise your hand. I would like to check and see.
I need you to show me so that it is. Oh, no, I know it.
Oh my gosh. Oh, never mind. I'm retarded.
Is there something?
Lighter, light.
Ow!
So like basically, how much is that?
My dad would
It just has to be. You don't need the another angle that would Okay, so go ahead. Okay, the two answers that I got, and there's more than one answer, are negative 40. Okay, so if we think about that answer first, we had negative 400. So we started here, wrapped around, got to negative 400. So I was like, well, what is just that piece right there? And so if you took 400 degrees and I'm subtracting 360, I get 40. Okay? And so from here to here, that is negative 40 degrees. Because you went around, or going down, around a whole 360, and then another 40 gets you to the negative 400. Okay? Now, positive-wise, if I'm going starting here and I want to get to this place right here, again, it's going to be 400 minus, or sorry, 360 minus 40, which is how much? 320 degrees. Question?
You just subtracted 400. Negative 400 is negative 360. Wouldn't that be?
You know what, you could think of it either way. You could be adding 360 to get your negative 40. I'm just thinking about the numbers, not the positives and negatives. Okay. Are there any questions on this?
No.
Okay. We already talked about reference angles yesterday. Okay. What are the three most important things we need to remember about reference angles? Okay. They are positive. Very good.
Less than 90 degrees.
Very good. Less than 90 degrees. Very good. Goes to the x-axis. So those are three things that we always want to remember about reference angles. Okay, we are going to turn the page. Are you ready? Yeah. Everybody have this? Okay. Did you get it all?
Oh, that's the one.
Okay. In a 360 degree angle, a point 1 unit from the origin. Okay, so they're talking about here, 1 unit from the origin makes 1 full rotation about. That means that what they're talking about is that any line on here will end up being a radius of 1. Okay, this is why we're talking about a unit circle. It's 1 unit around. Okay? Now, as you read here, cosine and sine of an angle is that cosine is the x coordinate, and we already talked about this yesterday. Cosine is the x, sine is the y. Over here is a little guide to help you. Cosine x, sine y, tangent is y over x. Now, we have our special right triangles. We all remember these, correct? But what we want to do is we want to use them on the unit circle, which means that the hypotenuse or the radius is 1. So I want to end up changing these so that this value right here is not a 2, but it's a 1. And this value right here is not a root 2, but it is also a 1. So do you remember how we fixed that? We know that across from the 90-degree angle, on here, it's actually 2a, correct?
Yes.
And so if I put 2a equals 2, and we divide by 2 to both sides, I get a equals, no, that's not what I wanted to do. Thank you. Candy for you. Okay, I want that as 2a equals 1. And so we divide by 2 to both sides, and we get a equals 1/2. Okay, so we want this side, which represents 2a, to equal 1. Are we okay with this? So this side across from the 30, this is normally a. So instead of it being 1, we're going to make that what?
1/2.
And this side is normally a root 3, which means we're going to make this what? 1/2 root 3, which we're going to end up writing this as root 3 over 2. Okay. Over here, this normally is a root 2. Okay, a root 2. This one was 2a. This was a. This was a root 3. Okay, just to help you guys out where we came up with these numbers. Because once we got a, we simplified. So this is a root 2. This one is normally a, and this one over here is also a. So if I want a root 2 to be 1, what will I do in order to solve for a? Divide by root 2. Okay? Now, can we have a root 2 in the denominator? No. So what am I going to do? Multiply by root 2 to both the top and the bottom, and that simplifies to be root 2 over 2. Which means that each of these sides are root 2 over 2. Root 2 over 2. And I would highlight these or circle these because it's going to make everything much easier when we get to these other problems. Okay, so I'm going to stop for just a minute so that I can clarify any questions right now on these triangles. So just to recap, I want this hypotenuse value to be 1. The reason why I want it to be 1 is because on our unit circle, the hypotenuse for every angle that you would end up every angle you would make on the unit circle is 1. And so I want these hypotenuses to be 1. We know based on these triangles that this side represents 2a. So if 2a equals 1, I solve and I get that a is 1/2. Based on that, because this side is a, this side is 1/2. The side across from the 30 is 1/2. The side across from the 60 is a root 3. So 1/2 root 3 is root 3 over 2. We do the same thing on this triangle, okay? We want this side, we want the hypotenuse to be 1, so I write a root 2 equals 1, and I solve for a, and then each of these sides get the a value. Do you want to ask me any questions? Okay, here we go. A lot of this is from yesterday, and then we're adding in some new pieces, okay? So we're going to start with drawing where 150 degrees is. So which quadrant will 150 degrees go to? Quadrant 2. So we're going to label that 150 degrees, and we draw our little circle saying it's going to that line. Our quadrant is quadrant 2. Now we need to find the reference angle. How do I find the reference angle? It always goes down to the x-axis. Very good. Okay? And we're trying to find this piece. I'm going to kind of color it in right here. That is your reference angle, this piece right here. And we know right here this is 180. And so we're figuring out, well, how much does it take from this line to get to 180?
30 degrees.
And that is 30 degrees. You could subtract. You could go 180 minus 150 and get 30, okay? Now, we are finding sine of this angle. So this is sine of 150, cosine of 150, tangent of 150. If this right here is 30 degrees, which we all agree with that, right? Yeah. Based on all the work I already did right here, what value is across from my 30?
1/2.
This right here is 1/2. What is going to be on this side, which would be across from the 60?
Root 3 over 2.
Root 3 over 2. And you could write the 1 here if you want to, but the 1 is unnecessary. Okay? And so we know that sine is dealing with the y, cosine is dealing with the x, and tangent is y over x. So what would be my sine of 150 degrees? 1/2. See how this is going on the y-axis. That is your y value. 1/2. Now, cosine, we didn't mark something. Did you guys notice something, how it's going to the left on the x-axis? What's it going to make that value? Negative. So, what is my cosine value? Negative root 3 over 2. Okay, tangent is y over x, but remember how our denominators will end up eliminating? And so we actually only have to write the numerator. Okay, we're only writing the top values of the y and the x here because that ends up, the 2's will cancel out. So, what would be tangent? So the y value is 1 over negative root 3.
Can we keep it like that, or we have to?
You want to rationalize it. So if you rationalize that, do you guys know what happens? What does it become?
Root 3 over negative 3?
Yeah, root 3 over negative 3, or the negative just has to be somewhere, okay? So this ends up being negative root 3 over 3. For those of you that don't know exactly how I got that, when we rationalize the denominator, we multiply by root 3 to both the top and the bottom. That gives you a pair of 3's, which is 3, and then 1 times root 3 is just root 3, or negative 1 times root 3. So you get negative root 3 over 3. You'll end up doing this a lot where you can rationalize it if you want to, but if you remember that this becomes this, you don't have to keep doing all that work. Okay, questions?
No.
All right, so negative 120 degrees.
3.
What quadrant will that end up being in? 3. Okay, so we're going to draw our arrow to here. We're going to draw our line. This is negative 120 degrees. If you ever have a hard time remembering, you can go 0. This will be negative 90. This will be negative 180 to help you remember where that would be. Okay, so quadrant 3 is where that's at. Let me make this a little bit better for video. Okay, so what would be my reference angle?
Negative 60.
Okay, so reference angles are always what? Always positive. So therefore my reference angle is what? 60 degrees. Okay, because this is 60, what value is going to be over here across from the 60 on the y part? Very good. Root 3 over 2, and it is negative because it's going down. And if you can't read that, I'm going to just circle that. That's negative root 3 over 2. What would be the value here for the x-axis? Negative 1 over 2 is correct. Does everybody understand where I'm getting these numbers? No? Okay, so looking at this triangle right here, across from my 60-degree angle is root 3 over 2, which we did all that work to find that. And so on here, see how that's a 60 degree? And so this line that's across from it, that y-axis part, it's going to be the root 3 over 2. And the reason why it's negative is that on your coordinates, remember that whenever you go left it's negative, down it's negative, up is positive, right is positive. So we just add negatives based on if it's going left or down or right. Does that make more sense? And so if across from the 60 is his, this is the 30-degree angle, and I'm sorry that I have so much writing right here, but across from 30 is 1/2. Going back up to here, see the 30 degrees? Across from the 30 degrees is 1/2. And so that's why this is negative 1/2, because it's going left, it has to be negative. So when we are filling out now the sine, cosine, tangent, again, it's the sine, cosine, tangent of that angle that we're dealing with. So that's negative 120 degrees, or just sine of negative 120. Okay, so what is the y value? What's my sine value? Very good, negative root 3 over 2. Cosine is my x value, which is negative 1/2, and then tangent is my y over my x.
Negative 3 over negative 1.
Negative root 3 over negative 1, which will reduce to just be positive root 3. Cell phones need to be put away. Okay.
Right.
All right, we're going to do one more problem on here. So 405 degrees, one more problem on this part. Where would 405 degrees end?
Quadrant 1.
Very good. Because we'd go 405 minus 360, and how much would be left?
45.
45 when you subtract. So we loop this around, and it ends here in quadrant 1. That is 405 degrees, quadrant 1. Okay, so my reference angle will be how much? 45 degrees is correct. Also remember, and this is why I say those 3 rules, it's less than 90. So if it's not less than 90, then you know, oh, I kind of made a mistake and I need to go back and reevaluate, okay? So 45 degrees. If we go back to our special triangle here, what goes on each of the 45 sides? Root 2 over 2. So we have root 2 over 2 and root 2 over 2. Are any of those negative? No. Okay, so sine of 405, cosine of 405, tangent of 405 degrees. Okay, so what's the sine of 405 degrees?
Root 2 over 2.
Good, root 2 over 2. What about cosine?
Root 2 over 2.
Good. And then tangent is going to be what?
2.
It's going to be root 2 over root 2, which reduces to be what? 1. Okay? Any questions? All right. We're going to turn the page. We're going to just do a couple more. This last section right here, down here, we're going to talk about this on Monday. We're still going to do it. We're just not going to do it today, okay? But this part right here we're going to talk about real quick. It says sketch each angle in standard position. Where would be negative 90 degrees? It's going to be right there. Would you guys agree? That is negative 90 degrees. Okay, so what happens there is that this is a specific point on the unit circle. Okay, all of them actually are specific points. But this right here is at 0, -1. Because it went 0 on the x-axis and then down 1. This point is at 0, -1. Does that make sense? Okay, 0 represents our x, -1 represents your y. And so therefore, what is the sign there?
-1.
-1, good. What is cosine?
0.
0. For tangent, it would be y over x, okay, which is -1 over 0. Can you ever have 0 in the denominator? No. So therefore, this one actually is undefined. There is no tangent of -90 degrees. It does not exist. Okay, 180 degrees. Okay, so you start here, this wraps around, here's your point. This is at
1, 0.
very good, 180 degrees, and that is at 1, 0. And again, I always like to label them x, y. So when, actually not 1, it's, thank you.
Talon said that. Piece of candy.
Okay, so what's the sine value? 0, what's cosine? And then for tangent, it would be 0,8 over -1, which is actually just 0. Okay, 360 degrees. Wraps around, ends right here. What point is that at?
0, 1. No, 1. No. 1, 0.
That's at 0, 0.
It's 1, 0.
1, 0. It's ending here at this point, which is always 1 unit, or 1 unit circle. Okay, +1, 0. X, y. What is my sine value?
0.
0. What's my cosine?
1.
1. And tangent would be 0 over 1, which does equal 0. So tangent of 360 degrees is 0. Okay, you wouldn't say it's 0 over 1. You'd actually say it's 0. Okay, the last one here, -270. We are going to go down and around, and it hits there, not past here. Okay, and what point is that at?
0, 1.
That's x and y, so therefore sine is
1.
1, cosine is 0, tangent would be 1 over 0, which is actually
Talon.
undefined, or no solution.
Undivided.